x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, welcome back. We're going to talk about multiplying matrices today. And multiplying matrices is more challenging than adding, subtracting, and scalar multiplication. There's a couple things that we have to remember. The first one, for matrix multiplication, it's a process of pairing the elements from the row of the first matrix and the column of the second matrix, and then multiply those pairs and then add the products together. The number of columns in the first matrix has to equal the number of rows in the second matrix of the multiplication, and the resulting dimension of the product matrix will have the number of rows of the first matrix and the number of columns of the second matrix. Let me show you what that looks like. So what this is stating up here is that we have, if we have a 2 by 3 matrix and another matrix multiplication, 2 by 3 matrix, that we cannot multiply them because we have to have the number of columns in the first matrix has to equal the number of rows in the second matrix. So this is the columns of the first matrix, and this is the rows of the second matrix. And if those two match, we can multiply. These two do not match, so therefore we cannot use matrix multiplication on those matrices, even though they have the same dimensions. What we need to do is look at another matrix, 4 by 2 and times 2 by 3. So if we have a 4 by 2 matrix and a 2 by 3 matrix, well, this time the columns of the first match the rows of the second, and so this is defined, and we can multiply, and the new matrix will have the dimensions of the rows in the first and the columns of the second. So this will be a 4 by 2 matrix. So I multiply 4 by 2 times a 2 by 3, and I'll end up with a 4 by 2 matrix. I'm going to show that one more time. So if I have a 7 by 3 matrix, and I'm multiplying it by, I'll just do matrix multiplication here, 3 by 2 matrix. Remember, if the rows of the columns of the first match the rows of the second, if those numbers match, then matrix multiplication is defined, and we can multiply to get a new matrix which will have the dimensions 7 by 2. And there's a little song that goes along with multiplying the matrices, and it goes something like this. Row by column, multiply them line by line. Add the sum and form a matrix. Now you're doing it just fine. And that's the rule. We're going to use that song and the rules we talked about to multiply this down here. So here's our first matrix multiplication example. We're going to talk here about a guy named Ruben. Ruben stops at the convenience store on his way to school to buy snacks. He buys 4 bags of chips at 30 cents each, 5 candy bars at 35 cents each, a box of cheese crackers for 50 cents, 3 packs of sour drops at 20 cents each, 2 bags of cookies at 75 cents each. So we have 2 different matrices we're working out of here. One, we have this price matrix. All right, the price matrix, 30 cents, 35 cents, 50 cents, 20 cents, 75 cents. And then we have the items matrix. What each item is, the quantity of chips. So 4 bags of chips, 5 bars, candy bars, 1 cracker, 3 sour drops, and 2 cookies. And so this is how the matrix is set up. And I want to look at the dimensions of this matrix. The dimensions of this matrix is, this is a 1 row and 1, 2, 3, 4, 5 column matrix. 1 by 5. All right, and this 1 stood for quantity. All right, so the first item here was quantity. And then this matrix is 1, 2, 3, 4, 5 rows, 5, and just 1 column, 5 by 1. And this was quality, quantity, and this was price. So what we're going to do is we're going to multiply these two together, and we know that we can multiply them together because these two inside numbers match. And if the columns of the first match the rows of the second, then we can perform matrix multiplication. So what we need to do is multiply each element in this row times each element in this column. So if you think about it, take this row and place it on top of this column. So 4 matches with 30, 5 with 35, 1 with 50, 3 with 20, and 2 with 75. So we're multiplying to get a 1 by 1 matrix, right? Our resulting matrix is going to be 1 by 1. So I'm going to multiply 4 times 30 plus 5 times 35 plus 1 times 50 plus 3 times 20 plus 2 times 0.75. And this will all multiply together and give us $5.55. And you can check that in your calculator, but really the math here is more important. All right, let's take a minute to try practice 1. So practice 1. Suppose Ruben's friend Terry goes along with him to the store. Terry buys a bag of chips for 25 cents, 2 candy bars, 45 cents each, 2 packs of gum, 30 cents each, and a medium drink for 75 cents. Create Terry's quantity matrix. Well, let's create a quantity matrix for Terry. So Terry's quantity matrix, how many things did she buy here? It looks like she bought 1 bag of chips, 2 candy bars, 2 packs of gum, and 1 medium drink. But then we have the cost of these items. So a bag of chips is 25 cents, 0.25. Candy bars are 45 cents, 0.45. 2 packs of gum at 30 cents each, 0.30. And the medium drink for 75 cents, 0.75. Well, first we have to see the dimensions and make sure that the dimensions match so we can multiply these. So this is 1 row and 1, 2, 3, 4 columns, so 1 by 4. And this is 1, 2, 3, 4 rows, 1 column, so 4 by 1. The middle numbers match up, so we can multiply. We're going to end up, our resultant matrix is going to be a 1 by 1 matrix. And so we're going to multiply these. 1 times 0.25 plus 2 times 0.45 plus 2 times 0.3 plus 1 times 0.75. And when we do the math, we end up with a total of $2.50 that Terry spent at the store. All right, I hope this is helpful. This is the first case. I want you to try practice number 2 on your own.